welcome to SADACon. We're very happy to have Panya Bahar, who's the lead scientist for speech translation at Aptec. Welcome, Panya.
Thanks for having me.
To start, can you tell us a little bit about Aptec and your role?
Sure. Aptec is a global language technology company specializing in artificial intelligence and machine learning. Our main focus is speech recognition, machine translation, text-to-speech, natural language understanding, and recently large language models. We put our expertise together and take a step further and develop a fully automated dubbing pipeline.
So speaking of, going more into detail, I guess, on AI dubbing, what is AI dubbing? How does it work? Tell us a little bit about what's behind the scenes.
When we talk about AI dubbing, or let's say a fully automated dubbing pipeline, this is a process of automatically revoicing a video from a source language, let's say English, to a new language for new audiences, let's say Spanish. The system not only transcribes and translates what is spoken, but also it needs to present the same voice, keeps the speaker's emotions while matching the body language and lip syncing. As it sounds, it is a very complex task. It combines a number of challenging aspects which needs to be addressed at the same time, which makes dubbing even harder than the sum of its parts. Generally speaking, it's a cascaded pipeline of speech recognition, translation, and TTS with other components in between, like speech separation, speaker diarization, and others. And each component needs to perform well as we have to tie them in the cascaded framework properly. Of course, at this stage, we cannot expect the system to produce 100% accurate dubbing, as I said, because it is challenging. And that's why in many scenarios, we need humans in the loop. We can augment each component with post-editing. Of course, it depends on client's budget. It's always a trade-off between quality and cost.
And you mentioned the kind of naturalness and expressivity that's possible now with speech synthesis and voice AI. What are the remaining challenges, or what are the next steps for speech synthesis, voice AI?
Yeah, actually, to be honest, still one of the main challenges is naturalness as well as emotional expressiveness. The models often have a flat tone, generating a speech with a human-like tonation and, let's say, stress that sounds natural remains still a challenge. The model also needs to convey a wide range of emotions like happiness, excitement, sadness, and so on. Besides these aspects, from the speech-to-speech side, when we generate speech as an output, I think the latency and efficiency of models, real-time processing, as well as objective evaluations should not be underestimated. These are also some factors which we really need to explore more.
And Aptec is obviously, you're creating these proprietary models, but do you also use large language models from, say, OpenAI, Meta AI, and so on? How does that relate to what you're doing?
Sure. These are the very high demanding models at the moment. In my personal opinion, LLMs have quite some potentials. When, for example, we talk about general large generative text models for machine translation, for example, these models have the same architectures as the state-of-the-art machine translation models, I mean the encoder-decoder architecture. However, they have been trained using a lot of training data, and they have billions of parameters, right? But it is expected to be better. These models are better, so why not getting benefits from them? What we can do, for example, for machine translation, we can fine-tune them by exposing them to bilingual text-machine translation data. We can use them to generate syntactic data for narrower domains like medical, or generating data for style and gender, as well as we can use them for translation quality estimations. Again, there are plenty of areas we need to explore.
That's great. That was so interesting. Thank you so much for sharing your insights today.
Thank you. Great to be here.